From the University of Illinois, Urbana-Champaign, and Illinois Public Media, welcome back to Weather Realness, a weekly podcast about the science behind weather and climate in Illinois. I'm your host, Maddie Stover, a doctoral student in physics here at the University of Illinois.
And I'm Jeff Frame, professor in the Department of Climate, Meteorology, and Atmospheric Sciences at the University of Illinois.
Remember, a warning means, the National Weather Service means that blizzard conditions are imminent.
So for the winter weather alerts, winter storm warnings remain until 6 a.m. on Sunday for Illinois.
Wind chill warnings and advisories are in effect. When we get in that 20 to 30 below range, like much of the viewing area is in, that's when you get frostbite in a half hour or less time on any exposed skin surfaces.
To talk about different winter weather advisories and how to stay safe during them, as well as what kind of weather to expect this winter, we are joined by Andrew Pritchard, meteorologist at Nutrient Ag Solutions. Thank you for joining us again, Andrew.
Happy to be here.
So, Andrew, can you break down the difference between a winter weather advisory, winter storm watch, and winter storm warning, kind of these different National Weather Service alerts that we'll see?
Absolutely. So a winter weather advisory here in central Illinois, it feels like sometimes in the heart of the winter, we can get a couple of these a week. Those are fairly common, and these are issued ahead of a winter weather event that's expected to bring snow of 3 to 5 inches in 12 hours, or sleet of a half an inch, freezing rain with sleet and or blowing snow. So kind of your general, we're going to have some winter weather impacts here and be aware of that. Winter storm watch, that means conditions are favorable for a winter storm event, which the winter storm warning, that's issued ahead of an event that's expected to be heavy snow of 6 inches in 12 hours or 8 inches of snow in 24 hours or sleet of half an inch or more. So that's when you're talking about a more significant winter storm that's going to be, slowing down or bringing travel to a stop or forcing closures of schools and infrastructure, slowdowns.
And then, Jeff, how about a blizzard? How is that different than a winter storm?
Yeah, a blizzard is a winter storm with 3 specific criteria. Number 1, visibility has to be reduced to a quarter mile or less due to snow. Now, a lot of times that snow is falling, but if you head up, for example, to the Dakotas, that can also be snow that's already fallen that's just blowing around. And so if you have blizzard conditions without any snow falling, that's what we call a ground blizzard. Number 2, we have to have strong winds. We look for sustained winds or frequent gusts to 30 knots or 35 miles an hour or greater, which again exacerbates that blowing snow issue I just discussed. And the third criteria is that those conditions must last for 3 hours or more. So if we have a little snow squall come by, it's a whiteout for maybe 10 minutes, that's not a blizzard, although that can be very dangerous for travel with sudden ice-ups of roads and sudden drops in visibility. The Weather Service actually has a product called snow squall warnings that take care of that, and it actually sounds the alerts on your cell phones.
So, yes, I was actually supposed to travel home to St. Joseph, Michigan, which is kind of along Lake Michigan, western part of the state, for Thanksgiving, and we had a blizzard warning for 2 days. So we went to the National Weather Service website, and they said travel was life-threatening. So we were not able to get together, but pretty serious warning under a blizzard.
Yeah, that's no joke, actually. And if you remember how cold it was around Christmas in 2022, there was a major lake effect snow event in Buffalo, New York, with blizzard conditions, strong winds, and very cold air with wind chills well below zero. And there were some people just either they had to go to work or they were determined to get wherever they were going or go grocery shopping, get that ham for Christmas, whatever they were doing. And in the city, they got stuck and dozens of people died of exposure actually in an urban area because visibility was zero. They had no idea where they were. They were lost. They were disoriented. So yes, travel can be life-threatening in those situations.
And so kind of on that topic, when we have these, different levels of advisories from the National Weather Service, what kind of different precautions do we want to take? Maybe starting with winter weather advisory, winter storm, and then working up to blizzard.
Right. Well, with any type of winter weather, the number one thing that most people do that would be affected would be travel. Obviously, driving can become very slippery and very hazardous. Walking as well, right? Untreated sidewalks can sometimes be slippery. We saw that on campus back on Monday after the weekend snowstorm. And even things, right, like the buses, if you rely on public transportation, those can also be delayed because they're driving on the same roads. that everybody else is. And airlines as well can be affected by that. And especially some of the flights into and out of Champaign, like from Champaign to Chicago, those shorter haul flights tend to be some of the first to be canceled. Because if somebody absolutely needs to get from here to Chicago, if the plane's canceled, right, they can drive, versus somebody flying from Chicago to San Francisco, for example, you can't really drive that very easily or very quickly.
If we anticipate a winter storm, people are kind of wondering, like, should I change my travel? Should I alter my plans? Andrew, what's the best place to get information about winter weather?
I always point people towards their local National Weather Service office. That's going to be your regional experts on meteorology that is local to your area there. So you can find that website by going to weather.gov, and then there's a box there where you can type in your zip code or your city, and you can pull up your location there and dive into some of the deeper discussions there. But they are going to be kind of the main entity there who's putting out the most accurate weather forecast tailored to your area versus relying on some of these other sources like social media or, your free weather app, which, as great as it is, maybe just kind of regurgitating some inaccurate weather model back at you. And I was getting I was getting shown a lot of screenshots leading up to the winter storm here in central Illinois of some really wildly varying snowfall forecasts here as the raw forecast model was kind of jumping around there with the forecast. So again, your local National Weather Service, they are your experts who are going to be deciphering all of that and putting together the story of the storm as it makes its way in.
Yeah, or local broadcast meteorologists are also an excellent source of that. Social media, again, you got to be very careful. So, trusted people like Andrew, like myself, are great, but, extreme Midwest Weather Center, probably not where you need to be going for some things like that. And I just made that up. I have no idea if that page actually exists.
There are a lot of different accounts on social media. When my folks and I were trying to plan what we were going to do over Thanksgiving, my mom was sending me so many screenshots on Facebook, and I was like, how about we go to the National Weather Service website, and they'll just be able to give us a clear sense of what we can and can't do. But yes, Andrew has a Facebook page, Shambana Weather.
But like Jeff said, your local media, your TV meteorologists and local news entities, they're oftentimes going to be relaying what the National Weather Service is forecasting, or are oftentimes in communication with the National Weather Service putting together the forecast. So they're connected there and are a trusted resource, absolutely.
If you mentioned before wind chill, what is the wind chill and why is it dangerous?
Wind chill is a measure of heat loss on exposed skin due to a combination of cold temperatures and wind. So, of course, humans are warm-blooded animals, and so we try to maintain a constant body temperature of about 98.6 degrees Fahrenheit. And so that our warm bodies naturally warm a thin layer of air around us. And so if it's not windy, that warm layer of air stays next to our bodies and we feel relatively warmer. However, if it's windy, that warm layer of air gets blown away and we're exposed to much colder air, and so we get colder much more quickly. And so that allows for cold weather ailments such as frostbite to set in a lot quicker in windier conditions. And wind chill, as important as it is, still doesn't take into account things like sunshine, you're going to be warmer in the sun, or precipitation, right? As snow or rain falls on you, you get wet, and then that evaporates. Well, evaporation cools you off. That's why you get cold when you get out of the shower, hopefully every morning, right? Evaporation is a cooling process. And to alert people of very low wind chills, the National Weather Service has a product called a cold weather advisory. These used to be called wind chill advisories and wind chill warnings, but they just renamed it to cold weather, I guess to be more clear to the people they're trying to communicate with.
And what wind chill temperature should we be concerned about? Is it best to just kind of look at that product from the National Weather Service, the cold weather advisory?
Basically, the lower the wind chill is, the more dangerous things are going to be. So, for example, if the wind chill is around minus 15 or so, exposed skin can suffer frostbite in about 30 minutes, in about half an hour. Going down lower than that, a wind chill, say around minus 30 Fahrenheit, exposed skin can freeze or get frostbite in as little as 10 minutes. So, that's kind of an average walk here around campus, right, from one building to another. And then when we get down to minus 40, minus 50, That's the really serious stuff where really you don't want to be spending any time outdoors unless you're completely bundled up. Hats, scarves, gloves, multiple layers, where exposed skin can freeze in as little as 5 minutes.
You're listening to Weather Realness, the weekly podcast about climate and weather. We're talking about winter weather with Andrew Pritchard, meteorologist at Nutrient Ag Solutions, and Jeff Frame, professor in the Department of Climate, Meteorology, and Atmospheric Sciences at the University of Illinois, Urbana-Champaign. So, Jeff, another winter phenomena, what is an ice storm and, how does it form?
Right, so an ice storm is when ice, as opposed to snowflakes, fall out of the sky. And it can take two forms. One is what we know as sleet. In American English, that refers to frozen raindrops or ice pellets. They accumulate a lot denser than snow, so about 3 inches of sleet per inch of liquid water. And it accumulates a lot like sugar or sand or something like that. And it's slippery, but in terms of an equivalent amount of snow or freezing rain, it tends to be less of a nuisance. Whereas freezing rain is falling supercooled raindrops. And both of these types of precipitation require snow falling out of a cold layer into an above freezing layer of air where it melts, and then into a below freezing layer of air down near the ground where it either refreezes sleet or becomes supercooled in the case of freezing rain. Now, freezing rain is a lot more dangerous because that freezes when it hits something cold into glare ice. And so that is very, very slippery. And any amount of freezing rain on an untreated surface is very slippery. Even something like 1/100th of an inch, basically the lowest amount of precipitation we can measure, can be very slippery if we haven't salted or put brine or something down on that surface. And that's for both walking, driving, whatever you want to do. So any amount of freezing rain is a real big inconvenience. And larger amounts of freezing rain, so maybe a 1/4 inch or a little more if it's really windy, or maybe 1/2 an inch if it's not windy. Well, that freezing rain also freezes on power lines and trees and things like that, and it begins to weigh them down. Ice is almost as heavy as water, and a cubic yard of water weighs about a ton. A cubic yard of ice weighs about 2,000 pounds. So this stuff isn't light. And, you have a big tree there, a big tree limb, that starts weighing that down a lot more than the leaves would. And so those power lines can fall down, or trees can fall on power lines or fall on roofs, leading to power outages. And then compounding this, it's cold, it's below freezing. But again, those power outages really only occur for about 1/2 an inch or more of freezing rain, whereas the travel impacts, any amount of that is really going to mess up travel unless the road crews have been able to get out there and treat things before the storm starts.
So is it accurate to say that we'd be more likely to lose power from freezing rain than from, just typical snow?
Yes. Yeah, snow, when snow causes power outages, it tends to be a lot of it that's very heavy and very wet that can weigh down things. Or the other thing is if we get snowfall maybe in like October, which is pretty rare around here, happens a lot more frequently farther north, like up into Wisconsin or parts of New York State, where you still have leaves on the trees, and then you're adding the weight of the snow on top of the leaves, and then limbs can come down that way. And again, I'm not a plant biologist, but I think that snowfall is one reason why deciduous trees evolved to lose their leaves in the winter.
And then, Andrew, how about freezing fog? What is that and how does it form?
Well, there's a lot of complicated stuff that goes into winter weather forecasting, but this one is as easy as it sounds. This one is fog that forms when the temperature is below freezing. So we talked earlier in the episode about relative humidity and trying to saturate the air. So if you can think of a day when maybe the temperature is 28 degrees and we've got our dew point is 28 degrees and we've got relative humidity of 100%, we have saturated the air, so we've got fog. But the air is 28 degrees. It's below freezing. And so are, too, then the objects that are existing out there, trees and, again, fences and power lines. And you can accumulate some fog on there. This is not the same heavy weight sort of ice that we're talking about with the freezing rain event, it's often very pretty when we get these freezing fog accumulations on something like a chain link fence or something like that, or on some of the tall grass or tree branches or something like that. But it's a fog event that occurs when we've got those sub-freezing temperatures, and so those fog droplets, they can be super cooled and condense onto some of the sub-freezing objects out there.
And have we had that, in the near past in Illinois?
Absolutely. I mean, we typically see it almost probably a couple of times a year, if not more than that. It takes kind of a unique situation, and not everyone is one of these really dramatic events, but just going back to this past winter, I want to say that it was February. I was traveling a little bit south of here down into southern Illinois and parts of southern Indiana, and they had a really widespread freezing fog event. And it was one of those where, you took a closer look to some of the chain link fences and the tall grasses that were lining the roads there. And there were some really unique crystal and just very pretty accumulations on some of the objects there. But I wouldn't say it's a super common thing, but it's also not extremely rare either that we can get these events here. And it's often as, maybe we're, trying to get rid of a snowpack and we're putting a lot of moisture up into the air or something like that.
And also with freezing fog, too, it's not like freezing rain with the slippery travel, but some of those supercooled water droplets that make up that freezing fog can also freeze onto, again, untreated surfaces. But again, the slipperiness does tend to be a little less than with freezing rain or freezing drizzle.
What is La Nina and El Nino, and how does it affect our winters?
Yeah, La Nina and El Nino are periodic coolings and warmings of water temperatures in the equatorial eastern Pacific Ocean, so roughly the area west of South America, west of Peru. La Nina is Spanish for the girl child. El Nino is Spanish for the boy child. And if you're wondering how they got their names, this is one of my favorite pieces of weather trivia, actually. Hundreds of years ago, the Peruvian fishermen actually noticed every few years the water temperatures would warm there in the eastern Pacific Ocean. And when that happened, the fishing conditions tended to be relatively poor because those warm waters were nutrient poor. And so they had no idea what was going on, and so they just called the thing El Nino because it tended to peak around Christmas time. So El Nino is actually named after Jesus Christ. So that's a random piece of weather trivia for you. But even though we are nowhere near the equatorial Pacific, El Nino and La Nina have weather impacts around the Pacific and also really around the world, including here into North America. And so El Nino, being the warm phase of water down there, what that tends to do is intensify the jet stream coming in off the Pacific. To get a strong jet stream, you need warm air next to cold air. And so it's colder. It's cold to the north, it always is, but now it's warmer to the south. And so that stronger jet stream brings a pretty active storm track across the southern U.S. Tends to be a lot of rain in California in El Nino years, and a lot of rain and rainy and relatively cool conditions across the southern U.S. Here in the Midwest, we tend not to see as many intrusions of Arctic air during El Nino winters. So they tend to be a little warmer than average, and sometimes much warmer than average, depending on the strength of the El Nino event, how warm that water gets there in the equatorial Pacific. La Nina, on the other hand, that's the colder phase. That's actually better fishing conditions. Unfortunately, no fun story on how this was named. The warm phase was the boy, so we'll call the cold phase the girl. That's just how that happened. But now our jet stream tends to be a little bit weaker coming in off the Pacific because now it's colder to the south, but it's still cold up there to the north. So weaker temperature contrast will give us a weaker jet stream there. And that weaker jet stream tends to allow for more cold air masses to be introduced, especially into the northwest and north central United States. So Montana, parts of the Dakotas tend to see cooler than average winters during La Nina events. Here in the Midwest, it tends to be a little bit more changeable between warmer and colder winters on average during a La Nina.
And so has this kind of weak La Nina been affecting our winters so far, or is it a little early to tell?
It's a little early to tell on that, but it has been, again, a bit cooler than average recently, again, across parts of the Northwest and Northern Plains. And certainly that storm track we saw over Thanksgiving would be consistent with that. But I want to stress that El Nino and La Nina are not individual storms. They don't make floods. They don't make snowstorms. They don't make landfall. But kind of like climate change in a way, they make certain weather events more or less likely.
Perfect segue. The next question. So kind of taking this kind of longer climate view. So Andrew, Illinois state climatologist Trent Ford has said, in earlier shows that our winters are getting warmer due to climate change. Can you talk about how that can be true given this, very cold winter that we've already experienced?
Absolutely. Well, Trent is correct. If we look at the last few decades, our winters are getting warmer. And as we just kind of reflect over the last 5 to 10 winters, it seems like you can pull out this narrative where it feels like November and December have been really quiet and mild. And then suddenly in January, we get hit with 2 to 3 weeks of really severe winter. And then it kind of fades in February. And we're talking about tornadoes in March. So it does seem that there's kind of a storyline there. And as Jeff just said, this kind of just makes things a little bit more or less likely. So as we warm, year over year, decade over decade, it takes away that cold air that we need for snow, as we talked about early on in the episode here. But every winter is going to be different. There are La Nina events, El Nino events. There are other things that are kind of steering the overall pattern here. And so this has been a bit of an anomaly here where we brought in a lot of that really cold air early in the season. So we've been able to get some snowfall events here and experience some bitterly cold temperatures and talk about wind chills. But this is not a guarantee that this even runs out through the rest of this current winter. I mean, it's still very much on the table. This could finish as a near normal or milder winter here if we don't continue this for the next couple of months.
Right. Earlier, I mentioned Christmas 2022, that real big cold snap that a lot of you probably remember. And you remember that about that winter, but you don't remember much of anything else about that winter except for maybe the 9 a.m. tornado at the end of February 2023. Why? Because that winter, except for that period right around Christmas, unfortunately for a lot of people, was warmer than average. But it doesn't mean even in a warm winter you can't have a cold snap. And one thing we see with climate change, for example, is that our heat waves in the summer are getting worse and more frequent, and our cold waves in the winter are becoming less frequent and less intense.
Yeah, well, go out there, enjoy the snow while we have it, and stay tuned, stay plugged in with the National Weather Service, WILL, and Weather Realness as the winter continues on, and we might see some more winter storms. Thank you so much, Andrew and Jeff, for joining us.
Thank you for having me. I love talking about snow, and I love the snow.
Always a pleasure. I like the snow in the first month of the year. Talk to me about it in January and February if this continues.
Andrew Pritchard is a meteorologist at Nutrien Ag Solutions, and Jeff Frame is a professor in the Department of Climate, Meteorology, and Atmospheric Sciences at the University of Illinois, Urbana-Champaign. If you have a weather or climate question you want us to tackle, leave us a voicemail at 217-333-2141 or email weatherrealness@illinois.edu. Weather Realness is produced by
Jeff Frame,
Trent Ford,
Steve Nesbitt,
Reginald Hardwick,
and myself, Maddie Stover. Funding for this podcast is partially provided by the Backlund Charitable Trust. Weather Realness is produced by the Department of Climate, Meteorology, and Atmospheric Sciences at the University of Illinois, Urbana-Champaign, and Illinois Public Media. We'll talk with you again next week.